Hi, we're here for the fifth exercise of the data mining lab, which is the support vector machine algorithms which are going to be applying. So this is a machine learning algorithm which is used in machine learning concepts to test classification and regression. So let us use a sample data set which is called as, let me minimize my toolbar to the end, one second, yeah. So let us use a sample data set called as sonar. So I drag and drop it, so it's automatically retrieved. So when you look at the output, you see what kind of data it is because you never worked with this before. So when you click on the output, so these are the different attributes, and there's only one class called rock, and there are almost like 60 regular attributes, like you can see. So there are 60 attributes. So this is how it is. So now let me going back to the design. So now we need to apply the support vector machine, but that will be inside our validation step. So first we have to validate whatever data set we get. We're going to use cross validation. One second, validation. So yeah, so we'll use cross validation. So as let me show you inside. So as you all know, a cross validation has two steps: the training and testing set. So in the training set is when you apply a particular model. The testing phase is when you test the performance of a particular model. So the training phase, we use the support vector machine. So we have it built in inside the predictive modeling. So we drag and drop it. We give this input, and then we also give the mod and this as the input to the next testing phase. Yes, so this is done. So in the testing phase, first we have to apply the model. We use the apply model operator, and we also use the apply model operator, and we also test the performance. So here we give this both as the input, and then we test the performance using the generic performance operator. One second. Yes, that is it. So we apply this, we give this as the input, and then we give it as the output. So this is how our support vector machine works. So inside the support vector machine operator, we have the particular parameter. Mainly the kernel type and the C value are the most important things, as they can cause a huge change in the performance. So now let us go back, finish it, test the results, and then apply the other cases. So going back to the process, we also connect the outputs and the outputs. So now we have to say go. So when you say go, you actually get the result. So these are the results. So you see that the accuracy is 78.86 and the precision is 80. The recall value is 80.98. We also have the AUC, optimistic, pessimistic, and normal AUC for the graph. So we have the different graphs. Now let me also show you the kernel model. So there are 208 support vectors. So the offset value of 0.207, and these are the weights. So these weights vary from 0. They go on. So if at all it's above a particular weight, then we call it as first class. If it's below that, it's called second class. So now let me show you by varying the parameters inside the support vector machine. For example, when I say radial, and then when I say go, you can actually see the results. So there's a change. You see that actually gone down by almost 20%. Even the precision, the recall value is increased rather, but even the graphs are plotted differently. But now let me show you by altering the C value. So when you alter the C value, let's say 0.1, and then when you say go, you see that the results again are different, and the accuracy is different, and precision different, recall value is different, and all that. So you see that both of these factors can greatly influence the the values of the support vector machine operator. So now see the kernel model also, you remember that is 0.207 in the beginning, now 0.913, and the weights are also changed. It was all from 0 to 1 before, and now it is changed so much. So that is how the support vector machine works, and it's very essential and useful in classification and regression. Thank you for watching.